Um, Say this is an operator, some operation on X in general. We say it's a linear operator if this is the case. If you multiply its argument by a constant, it's the same as multiplying the whole operator by that constant. So let's look at this combination. And now we'll say all these x's are vectors. And kind of say the whole set of vectors is the argument of this little operation here. If I multiply all those guys by the same constant, it's the same as multiplying this whole thing by that constant. So this is a linear operation, and we call it a linear combination. This thing is going to crop up a lot. Get used to looking at this thing. Okay, definition of a span. If you're given a set of vectors, what does it span? It's the set of all vectors that can be produced by any linear combination of those vectors you were given. That's called the span of the given vectors. So this is an example of, we're given A and B, pretty simple looking vectors. Here's a generalized linear combination of them, and mean this, which reduces to this guy. I can pick the seeds. So if you give me any x and y point in the two-dimensional plane, I can generate it just by setting C1 to x and C2 to y. So the span of these two vectors is the whole 2D xy plane. That's the span. In this case, you can visualize it. What about these two vectors, 1, 2, and 2, 4? Well, you'll quickly notice that B is just twice. If I do that linear combination of them, I just get some multiple of A or some multiple of B. But whatever I get is going to be a multiple of vector 1, 2, which is this line going through the origin, where y equals 2x. It goes all the way through down into the fourth quadrant, third quadrant. So its span is just a line through the origin. In this case, it was the whole plane. If you gave me the zero vector and say, what's the span of the zero vector? I just get 0, the origin. Span of 0 is the origin. We've got a point, origin, a line through the origin, and a plane containing the origin. There's 3 examples so far of spans. I think I'll stop this short guy right there. That's the span in linear combinations.